Solids or liquids or gases? Where the diffusion is more faster? Means where faster?
Gases, sir.
Gases. So that is what I have taught you in yesterday's class also. So if it comes to here, understand? So the diffusion is very faster. The diffusion is very faster in gases. So that is what we are going to study in the today's class. So diffusion in gases. So all of you can keep heading diffusion in gases. So let us comes to here. As we know that diffusion in gases is very fast compared to the liquids and as well as compared to the solids. Very fast. Why that? Why? What is the reason behind? Anybody? So because if you observe here, the particles in the gases moves very quickly in all the directions. Are you understanding? Solids it will take, particles are very tightly packed so that they have a very less kinetic energy. If you observe the liquids, liquids have less loosely packed, understand, so that they can go a little bit faster. But if you observe the gases, the particles are very loosely packed and they have highest kinetic energy. Understanding? Most kinetic energy is present for this. Understanding? So, maximum kinetic energy. Maximum kinetic energy is present for this so that they can move in all the directions very faster. So that is the reason behind diffusion of gases. Why the diffusion of gases is very fast? People will ask, you people can say, I will say the real life examples also. Because the particles, the gas particles moves very quickly in all the directions. In all the directions. That is what the reason behind it. Understand? So if you observe here also again the parameter which will defines the rate of diffusion means how fast the diffusion is taking place or how slow the diffusion is taking place. That is only which to called as rate of diffusion. Understand? So this rate of diffusion is again depends on a parameter called as density. That is you should remember. So if the density is less, then the diffusion is much faster. If the density is more, then the diffusion is much slow. That is what you should remember. So if we take the gases, both are gases only. So in which one the diffusion is much faster means the gas which is, understanding light in gases, the weight is light means in the sense of the gases which is having low density, they can diffuse faster than the heavy gases. Means in the sense of light gases who is having less density, light gases diffuse. If you have doubt, you please ask me. Diffuse faster than heavy gases. Do you understand Tamil Selvan? In gases, basically the gases, the diffusion is very faster. But in the gases also, those who are having low density are less denser in weight, means in the sense of light gases. So their density is, much lesser, so that the diffusion rate is much more. Do you understand, Amma? So here 3 points I should tell you. Diffusion in gases is very fast compared to the liquids as well as solids because the particles are present freely and they have the maximum kinetic energy. So that they can easily move in all the directions. Much faster, very quickly in all the directions. Understand? Because of maximum kinetic energy. And also this diffusion of the rate of diffusion again depending on the density. Understand? If the gas, any gas, I'm having two gases. Now one gas is low density, one gas is a little bit more density. Then the low density gas is having much more faster, the diffusion rate is much more faster than the gas which is having high density. That is what you should remember. Understand? So now let us give some examples. Understand? Suppose you can see that in yesterday's class I have shown you the diffusion of gases is usually like bromine gas and air. Have you remembered? Bromine gas and air. Do you remember or not? Bromine gas and air I am mixing inverted and
Yes, sir. Yes, sir.
in the brown color. Do you notice it or not?
Yes, sir.
Yes, in that also you observe. Who is more diffusing, air or bromine gas? Who is having less density? Compared to the
R, sir.
less denser than bromine. But we can see only the bromine color because air is the colorless gas. Air is the colorless gas. Do you understand, Amma? So that is what. So let us come to our real life examples. Understanding some examples of diffusion in gases from our everyday life. Now, how many of you know cooking? How many of you know cooking? Cooking. Everybody, is there any home without cooking? Every home they used to cook something every day.
Sir.
Yes or no? Particularly what is happening? If you take any kind of, suppose now, every day we people used to cook something, correct? Your mother or somebody who is your servant or your cook, somebody they used to cook some food in our home. Yes or no? Now, have you noticed it? Suppose you are sitting in a hall or else you are sitting in your bedroom. Also, you can see the smell of food, it is being cooked in the kitchen, reaches us even from a considerable distance. Is it yes or no? When we are even sitting in a hall,
Yes,
or
sir.
somewhere, whatever your mother is preparing, definitely that smell will be reaches to your nose, so that we can guess, oh, today my mother is going to cook chicken or mutton or something. Is it yes or no? So here you see, there is no physical contact and we are not in in the same room, but we are getting that smell. Why? Why? Can you able to say anybody, please? Why it is happening? Sir, I am using everything solids in the food. Suppose vegetable, chicken, whatever it is. I am using a solids. But how it is happening? Can you explain, please? You are 9th class children. Anybody? Darun? Alana? Anybody you can speak. So what is happening? When I start heating, so how the smell is coming? How it is reaching to the, even though I am sitting in a considerable distance means, few houses particularly in village you may see, not here, village. Understanding, if they are preparing something, when you are moving in the street, itself you can smell it, what they are going to cook in their home. Is it yes or no? Yes? Particularly our
Yes, sir.
village fellow, we can smell easily. So what is happening here exactly means, remember, when the food is cooked, you remember, when the food is cooked, so that it contains so many things. We are adding so many, understanding, like powders, like spices, understanding, and so many things we are adding. So what will happen means, some of the substances in food, they will release the gases. They will release the gases. Means the cooked food, when we are cooking, understanding, we are taking so many raw materials. So in that, some of the raw materials, understanding, they will release the gases, so that what will happen? The gases having the smell of food in them. The substances, they will release, understand, substances in food, they will release the gases which is having the smell of food in them. Means the same smell of food, these gases will contain. So that gases, the particles of these gases will very quickly mix up with the air. Understand? Very quickly mix up with air, so that what will happen? So the air will reaches to us. Understanding? So that suppose here air is present. Now the food gases is come to here, so that the diffusion will take place. So that they are both are gases. So that as we know that very quickly the diffusion process is very quickly will take place. So as we know that when air containing these gases will reach us to our nose, what will happen, Ra? We will get the what? We will get the smell of the food which we are cooking in our kitchen. Is it yes or no, Laksha? Have you observed or not in our daily life? Tamil Selvan, at least once in our daily life, you observed or not? Yes or no? Nobody is saying,
yes, sir.
Yeah. So, get this smell of food being cooked in the kitchen, even without entering into the kitchen also we can guess. That is what? Diffusion. Understand? So, the smell of this food being cooked reaches us even from a considerable distance. Why? Because of, by the process of what? Only by the process of What is the process behind it?
Diffusion.
Diffusion. Understand? Because the smell containing food gases will be diffused in the air, and that air will reach us to our nose, so that we will feel the smell. Understand? And suppose you can see, you people are all coastal areas, Tamil Nadu. Understanding? Suppose a fish is being fried in a home. Fish is being fried in a home means your mother is frying fish fry. Most of you people like, as well as I also used to like. So you can see that then a sharp smell, a peculiar, immediately you can observe that as a smell can be detected even we are very quite far off. Understand? When we are preparing the chicken or fish and all, immediately we can observe that smell because the diffusion of gases. Understanding this from frying fish is even much faster because the frying fish can produce even more amount of smell containing gases, so that they will diffuse in air much faster, and it will reach us to our nose much even fast. So that is the reason why we people can get the smell. If our mother is cooking, our mother is frying the fish in the kitchen, we people will get the smell in our, even we are very quite far because of diffusion of gases. That's all. So now let me take here the smell of hot sizzling food. Sizzling like in the sense of like, you know that, like what we can say, frying food. Nowadays you are eating Maggie or something. Sizzling food even reaches, understanding, when we are at a considerable distance, but get the smell of cold food, we are have to close to it. Have you noticed it? While our mother is cooking, in the sense of like when it is in gas, above the gas, when we are frying, that smell will be reaches much faster compared to the food which has been cooled. Is it yes or no? Suppose our mother prepared the food after 10 days, after 1 hour. If you smell it, the smell won't come. Is it yes or no? While she is preparing, we can feel the smell even much faster. Why? While she is doing the, understanding, sizzling means in the sense of, understanding, frying, sizzling, hot sizzling food, the gas can diffuse much faster. Why? Can you able to say? Yesterday I have taught you, when you will increase the temperature, what will happen? If you increase the temperature, what will happen? So many times you have told. Diffusion rate, what? Something will happen, Pradosh. That is what? If you increase the temperature, kinetic energy will increases or decreases?
Increases, sir.
Increases. That is what? Understand? If you take the cold food, means which has been become cool, or else a hot sizzling food, both can releases the gases. But a hot sizzling food, when we are preparing on the pan, or else when we are heating on the gas, then the smell will reaches much faster because particles will gain the more and more kinetic energy when heat is supplied to that. So that even though we are very far, we can feel that smell because it will reach us very fastly. But if we consider through the cold food, which will become cool, then if you want to smell it, we have to open the bowl and we have to go very close to smell it. While we are eating, if you come to the dining table, basically we will test what is the items prepared by mother. Is it yes or no? So by the time we will taste, open the lid.
Yes, sir.
Nice taste, like that we can say. Nice smell, like that people will say. Correct or not? So that is what. So when the food is preparing, then we used to get the smell, even though when we are very far. Once it is prepared and it's become cold, then we have to go closer to smell it. That's all. Understand? Because here what is happening? The diffusion rate is much faster than, understanding, much faster when it is in hot gases compared to the cold gases released by the cold food. That is what you should remember. So this is the first example of that. Now, coming to the second example, as we know that everybody, I think most of you, particularly girls, you can see, we people will go for praying every day, God. We used to keep the agarbattis for like a praying the God. Is it yes or no? Are you people?
Yes, sir. Instant stick.
So everybody will keep agarbatti, which we used to call as, what we should call? Incense?
Incense stick.
Incense stick. So now
Incense.
incense stick, if we'll keep it somewhere in our God's room, understanding, somewhere in the corner of our room, the fragrance means in the sense of the smell, the fragrance of, you can say that like it is a jasmine flavor, it is a gandham flavor, like that different flavors will come. Is it yes or no? Different agarbattis.
Yes, sir. Sandal flavor.
Yeah, so many flavors will be there. So, but we cannot see that. We can say when you are, even though if it is kept somewhere in the corner in our room, that fragrance, understanding, means in the sense of that the smell will spreads in the whole room very, very fastly. And we used to feel that agarbatti smell. Is it yes or no?
Yes, sir.
Why? Because the fragrance of this burning incense stick spreads all the direction due to the diffusion of smoke into the air. Means this fragrance, understand, will in the form of smoke. Understanding, this incense stick will release the smoke. The smoke contains this smell containing gases, means in the sense of fragrance of this incense stick, so that they will diffuse into the air in all the directions, so that we used to get the smell in everywhere. Suppose I have kept the incense stick in one particular corner. Is it only there I am getting the smell, or throughout the room? Throughout the room. Where I can get? Where I can get the smell?
Throughout the room, sir.
Because means in the sense of what? Gases are diffusing all the directions of the room. So that is what you should remember. Understand? So the particles of gases produced by this burning incense stick moves rapidly in all the directions, so that, understand, so they will start diffusing into the air, so that only the smell of this fragrance, the fragrance of this incense stick is reaching in all the directions. That is what you should remember. Understand? So now that's all. So this is the second example. Now you please genuinely said me, no, it is not bad thing. How many of you are using spray, body sprays? Everybody will use. Now I am not using. When I am in college, I will use. When I am in college, I used to use. Can you able to say? You people are using or not? I definitely will use perfume.
No,
Perfume definitely few times we'll use. Underarms or somewhere. It is not bad thing I am saying. Just I am asking. So as we know that bottle of perfume if we take, understand, bottle of perfume if we'll take it, so what will happen? Suppose when I'm in my, understand, in front of my dressing table or somewhere in my corner, so if I'll press that perfume in the corner of your room, but the smell will spreads in the whole room quickly. Is it yes or no? The smell will come in the room. Is it yes or no? Suppose I have sprayed spray here in my corner of my room. That smell will come into the other parts also not. Yes or no?
Yes, sir.
Why? Why? Can you explain it, anybody? Why? What will happen? What will happen? So what?
It diffuses with the air, sir.
Yes, the smell spreads in the whole room very quickly, because the smell of that perfume, whatever you are spraying, understand, spreads due to the diffusion of perfume vapors into air. Understand? So these perfume vapors, they will start diffused into the air, so that it will be reaches to our nose, so that only we'll feel the smell of the perfume. Understand? So when this, understand, if bottle of perfume is opened, then this liquid perfume changes into the vapor. As we know that now, what nadustundi India, you may know that fog nadustundi. Have you seen the advertisement, fog advertisement?
Yes,
What
sir.
in India presently, even
Pakistan.
Pakistan border also they have made an ad. Recently, you can see Pakistan border, all the Pakistan and Indian soldiers are talking. That Pakistan fellow will ask, what is going on in India? Fog going on. Like that they will say. In Telugu, I can say. Tamil, I don't know what is the ad. Have you seen it or not? Have you watched?
Yes, sir.
Yeah. So that fog, if will take, fog they will say, gasless perfume they will say. Means in the sense of inside completely it will be liquid. But whenever you will spray that liquid, it will be quickly evaporate. It contains alcohols. That is why gas can, that's the perfumes can catch fire. Have you noticed it? Perfumes can catch fire. Yes or no?
Yes, sir.
Yes, be very careful, because it contains, understanding, more volatile substance. Volatile substances means in the sense of like alcohols, understand, which can easily converting into gas state, which can easily converting into gas state. That is why if you spray the perfume, you can see, if you spray in our smell, if you go to the shopping mall and all, you spray here and you smell it like this for buying a new perfume. Is it yes or no? But after a few seconds, it will be automatically evaporated. Understand? That much fastly it will be. It's because it
Yes,
contains
sir.
so many alcohols, like our sanitizer. Don't use this as a fire instead of in front of fire. Definitely it will catch fire. Very, very dangerous. Particularly fog. Fog, you know, suppose if the fire is coming, if you spray the fog spray, then the fire will increases 10 times. That much dangerous it is. Very, very dangerous. Don't do that. That is why. Understanding. And even these perfumes are very dangerous. That smell should not be absorbed by our body. It contains so many chemicals. Understand? So that is why, if you'll observe, when this bottle of perfume is opened, then this liquid perfume will be converting into vapors. Particularly attar, Muslims can use. Attar, do you know that? Attar, if you'll touch here, at least the smell will be till 1 week. Yes or no? Darun? Tamil Selvan? Attar will be used by Muslims. Particularly like most of the Muslims will like the attar and all, attar smell. Well, while they are going anywhere, definitely they will keep the attar throughout the body. We cannot even, a few fellows overspray that we cannot bear that smell. Is it yes or no? More than limit they will apply. That is also very dangerous. Yes?
Yes, sir.
So, this is all the what examples of what that mixing the gases, diffusion in gases. Now, particularly you can see LPG. How many of you know LPG? We people are having in our home. In our home we have a LPG. Yes sir. No. What is LPG full form? Class 8 I only taught. Manya and Samya. What is
Liquefied petroleum gas, sir.
liquefied petroleum gas? So if we take LPG, suppose unfortunately our mother forgot to off the knob, understanding that gas stove, then we can see that the smell will be coming every part of the room. Is it yes or no? Immediately we can see. Understanding?
Yes, sir.
Gas is not closed. We have a particular smell for this gas. Understand? So that we used to get a very strong smelling present in this because of this cooking gas LPG. So that immediately we can say, "Amma, gas is not stopped. You please go and stop the gas." They will say, "Is it yes or no?" Yes.
Yes, sir.
Now, do you know
Yes,
what?
sir.
Here one I should say. Actually, the LPG gas which we are using in our home, it is a odorless gas. Means it does not having any smell. Really, I'm not joking. But when it is religious, we used to get a very deep smell. Is it yes?
Yes, sir.
Yes. Actually, our LPG is a colorless gas and as well as odorless gas. No smell and no color. But if you are using the same gas, then it is very dangerous. Is it yes or no? Unfortunately, I forgot to close the knob of a cylinder. Then definitely it is very dangerous. It leads to the blasting. Is it yes or no?
Yes, sir.
That is the reason to detect this smell. It is useful for us, but if it is religious, unfortunately, it is very dangerous. It will cause us the severe burning actions like blasting. So that is why while they are filling this LPG, liquefied petroleum gas in the cylinders, they will add a chemical substance called as ethyl mercaptan. All of you should note it down. Very, very important general bit. Understand general knowledge. Ethyl mercaptan, MER, it's a chemical. Mercaptan, understanding, is a chemical which is having a very deep smell. Understanding, a strong smelling compound. A strong smelling compound which will be mixed with the gas so that when the gas is coming out from the cylinder, this is also will come out. So that is why we people are detecting the smell. Do you understand, Amma? Understanding?
Yes, sir.
This only. Without this chemical, we cannot detect that smell. That is why I am saying general knowledge it is most important. Ethyl mercaptan is a chemical. Ethyl mercaptan. So this is all about diffusion in gases. Do you understand, Amma? Diffusion in gases? Yes or no? Yes? All of you?
Yes, sir.
No, right. Diffusion in gases. Diffusion in gases. These are the examples. You can write any one or two examples, but I will say diffusion in gases. Right. Diffusion in gases is very fast. Diffusion in gases is very fast. Manya and Samya, do you understand diffusion in gases? Alana? At least say yes. Darun?
Yes, sir.
Write it. Diffusion in gases is very fast. Diffusion in gases is very fast because diffusion in gases is very fast. Diffusion in gases is very fast because diffusion in gases is very fast because the particles in gases move very quickly in all the directions. Move very quickly in all the directions. The particles in gases move very quickly in all directions. Move very quickly in all directions. In all directions. All directions. Full stop. The rate of diffusion of a gas. The rate of diffusion of a gas. The rate of diffusion of a gas. The rate of diffusion of a gas depends on its density. Depends on its density. Depends on its density. Depends on its density. So which gases will diffuse much faster? Lighter gases or heavier gases? Heavy gases or lighter gases? Light gases or heavy gases, Ra? Which will diffuse much faster?
Light gases.
Light gases, right. Light gases diffuse faster. Light gases diffuse faster. Light gases diffuse faster than heavy gases. Light gases diffuse faster than heavy gases. Heavy gases. Heavy gases. Now, examples. All of you keep examples. 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 Examples you can write. The smell of food. First example one. The smell of food. The smell of food being cooked in the kitchen. Being cooked in the kitchen. Being cooked in the kitchen reaches us. The smell of food being cooked in the kitchen, being cooked in the kitchen reaches us even from a considerable distance. Even from a considerable distance. Example one. Next, second example. Second example. The fragrance of burning incense stick. The fragrance of burning incense stick. The fragrance of, what is the meaning of fragrance? What is the meaning of fragrance? Smell. Understanding? That is. The fragrance of burning incense stick spreads all around the room. The burning of fragrance stick. Sorry, the fragrance of burning incense stick. The fragrance of burning incense stick spreads all around the room. That is. Next, third one. The smell of perfume. The smell of perfume spreads due to the diffusion. Spreads due to the diffusion of gases. The smell of perfumes. The smell of perfumes because diffusion of gases. And last one, leakage of cooking gas. Leakage of cooking gas. So cooking gas means what, Ra? Cooking gas means what? CNG. Understand? So CNG contains a chemical name called as what? What is the chemical name I said?
Sir, LPG, sir.
LPG, okay, okay. LPG. So LPG contains what? Ethyl
Mercaptan.
Ethyl mercaptan. Because of this, we are getting a very strong smelling. So these all are the examples of diffusion in gases. Is it okay, Ra? Understand? All of you write it. Is it okay, Da? Completed? Okay.
Completed, sir.
Manya and Samya. Tamil Selvan. Alana.
Yes, sir.
Okay. So once it is over, then we'll go for the next concept. What is this, Ra? What is the next concept? Now diffusion in gas. What is the next concept?
Diffusion in liquid.
In liquids. So let us discuss now. First listen, all of you. Don't write. First listen. Later you can understand. So if it comes to here, diffusion in liquids. If you'll observe, like gases, the diffusion in liquids also will take place. But compared to the gases, it is slower or faster. It is slower or faster. It is slower or faster, I am asking. Compared to the gases, the diffusion is slower or faster. Padre, compared to the gases,
Faster, sir.
faster.
Sir, slower.
Slower. Lakshay is saying correctly. Nobody is saying. If you observe the diffusion, it is slower than. Understand? It is slower than. Understand? That in gases. Because why? Kinetic energy is lesser than the gases or not? The particles will move slowly as compared to the particles in gases. Understand? So if we take gas particles are very far each other, so that they are having a more kinetic energy, so that they will go much faster in gases. But if it comes to liquids, so liquids the particles are understanding little bit closely present, so that what will happen? They have less kinetic energy compared to the gases, so that they will move little bit slowly. Understand? Liquids move slowly as compared to the particles of gases because of less kinetic energy as compared to the gases. Now, let us discuss some examples of diffusion in liquids. Now, do you know that first we have studied potassium permanganate? Have you remembered? We have taken one beaker and we have kept a small purple color potassium permanganate. Have you remembered or not? Have you remembered or not? Potassium permanganate, purple color. Please tell me if you know or not. So if I fill with water, slowly the water will be turned into purple color. Do you understand? To verify the particles are made of, so matter is made up of small particles. We have done this experiment. Yes or no, Pradosh? Do you remember or not?
Yes, sir.
So if you observe here, I have kept a potassium permanganate at the corner, this corner. This potassium permanganate only we used to call as KMNO4. At least now you remember chemical name called as KMNO4, which is present in purple color. Understand? Now if you observe, if I filled with the water, this beaker filled with the water, then I can see the purple color of this potassium permanganate spreads into the whole water, slowly. So you can observe here, the spreading of purple color of potassium permanganate into water on its own. We are not doing anything. Just I am pouring water and I am leaving. So here why happening means because of the diffusion of potassium permanganate particles into water. So after certain minutes, if you will observe, this full water will be turned into purple color. Is it SR, Laura? Full water will be turned into purple color. Understand? Because
Yes, sir.
it means this potassium permanganate is slowly diffusing into the water so that the potassium permanganate is present in